in polar dielectric, that each molecule behaves as a dipole having the permanent dipole moment. So we just say that about this polar, there are inbuilt your dipole moment are exist, and each one of them will act as a permanent dipole moment. So now how it will behave when I'm just going to place in some external electric field E0. So assume that this is the dipole and that is a dielectric placed in some external field. So obviously again here the internal or the field will get induced inside that of your dielectric, but it will not cancel exactly to that of your external field. So the field goes on build up unless and until this external field is same as that of your this internally restoring that kind of electric field which exists between them. So then you can say that this minus charge on this left side and the plus charge on the right side, so which will induce your field inside that of your dielectric. So then we have to just define your dielectric constant also, and you have to define that polarization also. Now because of this process, you can say that just positive charges of the molecules will be shifted slightly towards the right and the negative charges shifted towards the left. So this right surface of the slab gets positive charge and the left surface gets the negative charge. So because of which we are saying that there is a formation of electric field and which is less than that of your external electric field. The net field you can write it down as a external minus your induced, that is nothing but your EP. So this is with the help of this diagram you can say that before that external field is 0 and when the external field is not equal to 0, so there is a formation of, you can say that dipole, that minus plus, they are always bounded to each other and their direction is in nothing but your direction of your external field. So likewise we know that this is minus and this is plus, so this is the kind of internal restoring force which exists from minus to plus. So it will try to balance your external field, and this is the direction. The resultant direction is always from your minus to plus. So this is your region of zero charge density. So this plus and this minus will get cancelled in this first and second column. Again in this second and third column, this plus and minus will get cancelled. But the overall there is a minus charge on this left face and the plus charge on this right face, so which will just induce your dipole. That is also we are going to define in terms of polarization also. So this is your reduced field in a dielectric, where you can say that E is equals to E0 minus EP. So the polarized dielectric is equivalent to the two charged surfaces with the induced charge surface density of plus and minus sigma p, one on the left face and another on the right face. This dielectric constant, we can just say that it is given by the ratio of your E0 by E. So that is also we are going to call as a dielectric constant, so which you have to define for that of your this dielectric material. Now what is this dielectric strength? We know that the electrons are bounded to that atom. It is not going to leave that orbits, but if you apply a very huge external field across it, then there might be a possibility of your electric breakdown. The electrons will leave from its that orbit and that will they move away. So that is nothing but your that is your, we can call as a your electric breakdown. So for each that your dielectric material, the dielectric strength is also defined, so there will not be any dielectric breakdown will occur. So that called as a dielectric strength. So just we have seen that the polarization means the number of dipole moments formed per unit volume. So when you place that your dielectric in some external field, the polarization will occur, means there is a formation of some surface charge density, the number of, you can say, the dipole forming per unit volume. So that simple concept is nothing but the polarization. So again you can define it in another way: the stretching of atom of a dielectric slab or the displacement of positive and negative charges under the action of some external applied field is known as a polarization. Or you can simply say that polarization is nothing but the number of charges, that is your dipole moments forming per unit volume, is also called as a polarization. This polarization density again develop per unit volume in a dielectric slab on placing it inside the electric field is called as a polarization density. So this sigma p, you can write it down as a qp upon A. Then q, we know that dipole moment of a dielectric, which is a qpd upon AD. This dd will get cancelled and you can write it down, that is a qp upon A, which is your sigma p. So the polarization is same as that of your surface charge density, where we said that polarization is the dipole moments forming per unit volume. The volume for that dielectric is A into D. Dipole we know that, which is qp into D, and which will give you the value of your polarization density. Now what is electric susceptibility? So we know that there is a formation of polarization when the dielectric is placed in some external electric field. So that polarization, that is the number of your dipole moments forming per unit volume, is proportional to your external field. So related to that, we can write it down that P bar is directly proportional to your E bar. Again you can write it down that P bar is equals to epsilon naught, that electric susceptibility into E bar. So you can write down that susceptibility in terms of P and E. So now how should I find the relation between that your K and that susceptibility? So we know that simple, we had the expression for that your electric field. So again we know that your K, where we are saying that it is the dielectric constant. So that dielectric constant, we know that E is equals to, we say that is a Q upon 4 pi epsilon naught K into R. So this one you can write it down, this is nothing but your E naught upon this K. So K is equals to your E naught by E. So this is your K. Now the resultant field inside this your dielectric, which is nothing but E, that external is E naught minus the field which is developed inside that of your dielectric. So let that is nothing but EP. Again we can find it, that is E naught. So this polarization is directly proportional to your susceptibility. So can also you can write it down, this external field in terms of that your external polarization. So we say that P is directly proportional to your this external field. So this is your external field, then you say that is proportional to susceptibility, then that epsilon naught into E is equals to your polarization. So just put this value, this EP is nothing but, again you can write it down, that is a E naught minus P. Then again this one you can write down, this is E naught, you can write it down in terms of that of your the surface charge density, and further after simplifying it you will get that your K is equals to 1 plus susceptibility. So that is the expression for your susceptibility and that dielectric constant, so which will give the relation between these two. So that susceptibility means how easily it can just get, you can say that the dipole moment has been induced inside that your dipole. So that is also, you can say that one of the term or the meaning of that of your susceptibility.